This Zoom session is being brought to you by the fractal Peace Anchor Black. Now, for tonight, we start with 9.3, then 9.4, 9.5. 9.3 is about exponential functions. Exponentials are of the form, just a second, f of x equals a to the power of x. So a is called the base, and x is the exponent there for the name. And it's different from x to a power. So it actually grows very much quicker. Just a second. All right. So, for example, here's a function y equals 2 to the x. 2 to the 0 is 1, so 0 by 1. 2 to the 1 is 2 up here. 2 to the 2 is 4. Every time you go over 1, it's twice as tall. Going back, negative 1.5, negative 1/2, negative 2, quarter, negative 3 1/8, and so on. So it starts very small and it grows very big very fast. Here are various exponentials. Here's 3 to the x starts smaller and goes fast. Here's 2 to the x starts a bit bigger and goes not quite as fast. 1.5 to the x starts bigger but grows much slower. 1 to the x is a constant. 1 to the x is always 1. They all go through 1 by 0 because 0 by 1 because a to the 0 equals 1. The 2/3 to the x is likely 1.5 3/2 to the x, only flipped left for right. That's because a to the negative x is 1 over a to the power x. 1/2 to the x looks like the 2 to the x flipped left for right. 1/3 to the x looks like the 3 to the x flipped left for right. So if you have a to the x and a is bigger than 1, you get what's called an exponential explosion. It starts very small and becomes very big very quickly. If a is between 0 and 1, then you get the reverse, the exponential decay. We don't talk about less than 0 because a to the negative 1, well, what is it at 1/2? Well, it's a complex number. So really, you'd have to graph in the complex plane. And since we're graphing in the real plane, we won't be doing that. Okay, now there are various uses of the exponential. One is in compound interest. We have a principal, P, an initial amount of money, invested for 2 years at a annual interest rate of R, and K compoundings per year. And A is the final value, the future value. Then the future value of A is P times 1 plus R over K to the KT. So it grows exponentially in T. So there's some examples from both. Y equals 5 to the x. Well, 5 is bigger than 1, so it's an exponential explosion. Starts small, goes through 0 by 1, then gets very big very quickly. 1/4 of the x, okay, 1/4 is between 0 and 1, so it's an exponential decay, like that. 3 to the x minus 2. Well, 3 to the x is an exponential explosion like that, but this minus 2 was down 2. These are all asymptotic to y equals 0. Subtract 2, it's asymptotic to y equals negative 2. 3 to the x goes to 0 by 1, but we subtract 2, it goes to 0 by negative 1. So it goes like this. Asymptotic to negative 2, so then it starts going very quickly away. Y equals negative of 2 to the x. Well, 2 to the x's goes like that, and you flip the minus, flips it up or down. Here they ask a finance problem. Suppose you have a principal of $10,000 invested at a rate of 8%, compounded 4 times a year. At a time of 10 years, what's the later amount? So here we go. The amount is P times 1 plus R over K to the KT. P is $10,000. There's 1. R is 8%, 0.08. K is 4. K is 4. T is 10. So 10,000 times 1 plus 0.08 over 4 to the power 4 times 10. That's 1.02 to the 40 times 10,000. And okay, calculating exponentials, you should have a calculator of some sort. Or maybe there's a calculator on your phone, or maybe you can access it by computer. Anyhow, you get $22,080.40. I think that 40 cents is being a bit too precise. But anyhow, 22. Somewhat more than doubles in those 10 years. How much more interest would $10,000 earn in 5 years compounded quarterly than at 5.5% interest at 5.5% interest and then at 5%? Okay, fine. Well, 5% you have your $10,000 here and here. 1 plus here it's 0.05 over 4 to the 4 times 5. It's 0.055 over 4 to the 4 times 5. So, okay, we work it out. 1282.04, 1314.07. The difference is $32.03. All right, that's it for this. Let's move on to the next. Stop recording.